Hey everybody, how are we doing today? It is a new week. It is Monday. 201 has a decision tree assignment. Hey, what's up, Jake? 474 has their coding exam. I have a smoothie. World is good. How is everybody doing? How is everyone doing? Jake, do you have questions about, I believe 474, right? Coding exam. Any questions? What questions do you have, Jake? Let's see here. Mubot's here also. Hope you're doing on the points. Check out your points, see how everything's going. Randomness. We do have yes, chapter randomness, Dan. Good to see you here, Dan. You've got the first question of the day. Chapter randomness. You know what we might do? We might bring up some of that randomness homework because that's going to be a big chapter coming up right here. So Dan asked the first question, chapter randomness. Let's go check out the randomness homework right here. It's one of my favorite homework assignments. And so I'm getting the homework up and going so we can start off with some chapter randomness. So good to have you here, Dan. And Jake, feel free to ask questions. 474, I believe. And let's see. We're getting everything up and going. Do you mind explaining the nested for loop example on the coding? Yeah. Well, we'll start with that. Let's do that. We'll start with that one. And then I've got the coding up right here. So let's see. Let me bring up the assignment because I know a lot of people are going to, this is a really good one. Okay. So we've got that. Let's bring up the nested for loop. And so here we go. Let's hop to the main screen. Let's bring, oh no, class is not over. So Jake stole my question. Awesome, Peyton. And then Dan, right after this, we're going to do some randomness assignments, which we can do tons of randomness here. You can just go to random normal. And you can generate 10 random normal numbers. These are all z-scores right here. You can do sampling to get randomness. So you could sample the numbers 1 through 10. And we'll move that out of the way right here. That's not the numbers 1 through 10. You could sample one number. So I could say, you could sample a coin flip. So you could flip a random coin right here. If you go heads and tails, and you could just flip, and you can just use this to flip a coin right here. You're like, okay, heads or tails? Who's tails? Tails again. Oh my gosh. I thought we would get like 5 tails in a row, but that's just randomly flipping a coin right there, heads or tails, so we can do randomness. But the question right now is about the nested for loop. So let me put a note. Nested for loop example. Nested for loop example right here. So with the nested for loop, what you want to do is, first off, I'm going to go here and store empty cars new. I'm going to store empty cars. So this is a new data frame right here. It's just the original empty cars, but I'm gonna write into it. If you notice in the key, this is what I did. But what you want to think about is we're going to store, I think, half of the values of the original value. So what you want to do is you want to go to position 1, 1, and you want to take what was in empty cars and store from position 1, 1, and you want to do half of that. So what did I do? I wrote to empty car new, and I wrote to position 1, 1, and I took half of what was in there. So you can see that's half of what it originally was. Does this make perfect logical sense what I wrote on line 9? Understanding what line 9 does is very important. It goes to the original empty cars data set, goes to row 1, column 1, multiplies it by 1/2, and then stores that value into here. So does this make perfect logical sense? Everyone following along right there? 2 seconds. Opening up a new Word document. There we go, we're back. I think we're back. So did everyone understand that line of code right there? Makes sense. Okay, cool. And so now when you think about a data frame right here, if I lose my pen, does it work normally again? Who knows if it works? So when you think about a data frame right here, with a data frame, you have rows and columns. So you have column, 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 row, row, row. And what we want to do is we want to go through all the rows, and then we go to the next, that's all the columns, oops. And then we go to the next row, and then we go to the next row, and then we go to the next row. So the first inner loop is going to go through the whats. Because you can watch the loop in action. Here it goes, you ready? I'll display it again for you. Inner loop, outer loop, inner loop, outer loop, inner loop, outer loop, inner loop. So the first inner loop will do what? I'll have to start at the what column and do what? The inner loop will do what? Just think theoretically. The inner loop is going to go from blank to blank. And the inner loop will go from blank to blank. Theoretically, it'll start at the which what and go to the what. So the inner loop, which I've noted right here, what's that going across? The more you can draw these and from first to last, yep, Lauren, you're right. And then Lauren, 100 points right there. I'm going to try to do 100 points this week and get people to 1,000 points total. It's going to go from the first column to the last column. So this is the number of columns right here in the data frame. We'll just put DF for data frame. So it's going to go from the first to the last. And then the outer loop will go from the first row to the number of rows. And we could count this up, but it's going to be easier if we just use code to find out how many rows there are. So that's going to be n row df. Just, I'm saying of the data frame. So it's going to go across here, going from the first to the last row. So when we think about this, we have our code right here. We can make it go across a column, and let's see this in action. So here's our code. And what have I written? What have I written? Right now, this is the only code I need. This is the only code I need. And what have I written? What have I written? And you can see my rows here that I'm going to go, or the columns here. I've written the skeleton. So I'm going to first do where it goes across each one of these and goes across. So we're going to take this code right here. We're going to go to 4. We're going to drop the code into here. And then we're going to go across each column. So I'm going to have to redo the code because it's going to overwrite the same things. But no, it won't. No one, because we have empty cars. We're fine. So I'm going to change the column. The column will be I. And this will be I. You know, just maybe you can't see. That's a J now. Placeholder doesn't matter. We just got to call it here. We want to go from 1 to the number of columns in this right here. There we go. And I think that'll do it because now we're going to go across. And what we want to do is we want to look at empty cars and make sure the first row has been changed. If you look, if you know the values in this, gears should not have 2. Carb should not have 2. AM was 1 because it's a categorical yes, no, but this is a practice thing. So we've done it. We've gone across here and we've gone across all of these. Now we need to use an outer loop to change it. And I'm just doing the kind of practice of doing this right here. So we're going to grab this code right here. We're going to take 4, and then we're going to put this code inside of here. Now we've built a nested loop, and I'm going to do the first row, first row, which will be across the top here, going across the values. And then I'm going to go to the second row, and then I'm going to go to the third row, and I'm going to go through all the rows. So we can make this K right here. And so there we go. Let's use I. I and J are very similar. And there we go. And let's go 1 through the number of rows. And now it's going to go from the first column across the top to the second column to the third. And when it gets done, it's going to switch the row. And I think we have it correct. I think we do. Only one way to find out. And that looks to be correct. I think we've done it. Unless I'm going mad, that should be it. And that's how we do it. Did that make a little bit more sense there as we built it up? I would clear out my work. This is no longer needed. But that's how we build the nested for loop. The most important thing is understanding the theory of how it works. And so you want to think theoretically what you're doing right there. And you're moving across all the rows and the columns. Now, the coding exam is really tough. I keep saying that. I understand if on coding night people are like, oh my gosh, this is impossible and there's no way to complete it. That's kind of the point. We don't want you to complete coding night. I know that sounds crazy, but I keep saying, if you've heard me say this, it's like an IQ test. There's meant to be more questions than you can do. If you complete it, you're an all-star. If you ace coding night and get every question right, you're a genius, because I'd have a hard time probably completing the whole thing. It is a little scary. I know, Lauren, it's a little and it's like, do you get each question? Can you do each question? And we try to write it as clear as possible. For most nested loops, with something like this, will the columns always be in the inner loop? And you can switch it. You could switch the two of them. Because if you think about it, switching it, really good question right there, Payne. Great question. If you switch it, it's just gonna go. It's gonna go this way. Oof. We need oof today. We need. So you'll get the same result if you do this right here. So we can quickly switch it. It'll still move across. So now our inner loop is going through the rows and our outer loop is moving it over one column. So you can see inner loop, outer loop, inner loop, outer loop, inner loop, outer loop. And that's what happens when we go here. We go inner loop, and then, this is the inner loop, because it goes through the outer loop first, then it goes to the inner loop, and it loops, and then it goes to the outer loop, and then loops. So you can switch it. You can go here to end call and end row. And what we could do, we call this 2. And just to confirm, oh, wait, what'd I do? Oh, wait. Did not do? Has 0 length replacement. That's got that. That's got that. What did I do, everybody? How did I break it that quickly? Error. Everything was working immaculately. Oh, did I not change one of those? I must have had an error in what I... End call, end row. Does it really not work if you switch it? I'll be. Oh, I see it. It's just me going too quick and not thinking. The way I have this set up, we're trying to write to a position that does not exist. So now it'll work, and I'm about to do a check that it turns out the same. Cool. There it goes. I need to switch I and J because I and J are positions for the rows and the columns. And since I had switched the way they were, maybe my reading comprehension is terrible, but can you explain exactly what 3.1 on the practice is asking for? Yeah, can you pop it in the chat real quick? And that way, as I check this right here, identical sees if 2 things are identical, and then we're going to hop and do a little randomness. But these should be identical. Yeah, they're identical. So kind of good a question about can you switch the rows and the columns, and then there's a code in R to see if the 2 objects are identical, rather than like looking through and being like, write a for loop that creates numbers 9 times 1 through 10. The for loop should display the numbers when it runs. Yeah, so when I did the answer for this one, the quickest way to do this one, and I guess we should do it the traditional way, is we should write something like this right here, 9 times 1, and then this is our skeletons. This is meant to be an easy question. Don't worry, it's meant to be an easier one of it. But now we're going to go through here, and we're going to change this to be the vector 1 through 9. Now, this right here, we need to print it. So it won't print if you don't do it. There we go. That's perfectly fine. I should have done it this way because maybe I added some confusion. Can you do 5.2? What's 5.2 say? Drop it in the chat real quick, and I will do 5.2. 5.2 is one of the last ones. Oh, it's the z-score one, right? 5.2 is the z-score one, I think. So it's right the way of doing the z-score. And we're going to do some randomness here in a bit. Sorry, Dan. We'll do some randomness, I promise. So the key is understanding what, how to do a for loop and the components of it. Yeah, and so I did it a little more complicated on the key. And also, so I've uploaded 2 keys to this. I should price an announcement about that. This is the answer I put on the key. I did it this way using special characters. And then I broke it. Where's my error? Yeah, that's what I thought. Didn't close it. Error in... Where do I have the error? Oh, is it too many of these? There we go. Code too quickly, make mistakes. Yeah, no worries. Yeah, let me do it. Let me do that right here. Which randomness one were you thinking about, Dan? Well, I do the z-score one. Which specific one? Basically, the key thing, if you're looking at some knowledge checks, statisticians use randomness as a tool. Randomness, so here's keynotes. Like, you should know these things instantaneously. They've been on true falses. I don't know what the exam is yet, but I can tell you statisticians use randomness as a tool. We love randomness. We're all about randomness right here. So statisticians use randomness as a tool, and when it comes to randomness, things don't have to be equally likely. Like winning the lottery is random. You either win the lottery or don't win the lottery, but you're not going to say winning the lottery has an equal probability of not winning the lottery. And some of the really hard questions. So let's hop and do one of those. So that one's easy. That one's easy. This one's pretty easy too. This one is the one that gets people right here. This is the one that just destroys people. So what you want to do, so watch as we do this right here. You copy the numbers this way. I bet someone in 474 or 320 is like, I remember this one. So if you notice, I'm going through the numbers. You have to do it this way. You have to go through the numbers. Then you have to copy. Then you need to go to a Word document and paste the numbers. And it double pastes the numbers. This is the thing most people don't realize, unless it fixed it this semester. And it might have. 5, let me check. Did it finally fix? No way. No way. Years? No way. Yeah, I don't know. It didn't double paste. They might have fixed it. So this might have fixed it. You want to make sure that, do you see the numbers here that are like 6, 8, 3, 7, 5, 1, 7, 6? And then the next row is 5, 4, 9, 3. For years, and I mean half a decade at least, the numbers double copy. And I'll check it on my Mac later, but on the PC, it did not double copy. And I kind of need to show it when it double copies because you got to deal with it. So we have all these numbers here. Now let's explain how to play this game. This is the tough question that most people get wrong on the homework. So when you play this game, have you ever played the game Sorry before? If you've played the game Sorry, you know if you're 10 spaces away from home, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go, 10 spaces now. You're 10 spaces away from home. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we got to be right here. There we go. You need to move 10 spaces to get home. Now, what are the numbers on a dice? You have to think first, what are the numbers on a dice? And we have that the number 6 is a number on a dice, but 8 is not, 0 is not, 7 is not, and 9 are not numbers on the dice. Now, you could go through here and delete all these manually, but if you hit Control F or Command F, you can search for these, and so you'll see the little down arrow, and you want to go to Replace. And so we're going to find 9, and we're going to replace it with nothing. So watch this. You see those 9s? They're gone. So do you want to continue from? Sure. Now all the 9s are gone. Now we're going to find 0 and replace all, and we replaced all the 0s with nothing. We're going to find 7, replace all the 7s with nothing. And I should have started at the start. And we find 8s, and we're going to replace all the 8s with, you got it, nothing. So what do we have now? If you look at our document, we have a bunch of dice rolls. So this is dice rolls right here, and we're going to make it all one big number line. And then we're going to learn how to play the game. Now, once again, when you play Sorry, you'll be rolling a dice, and the dice will be numbers 1 through 6. Now, when you play Sorry, that's weird. When you play Sorry, you can't go over. You can't roll more than 10. So let's play the game here. You ready? On your first roll, you roll a 6. So that means you're going to go 6 spaces forward. You're going to go here 1, 2, 3, 4, 5, 6. You're right there. On your next roll, you roll a 3, which means you roll 1, 2, 3. On your final roll, or not your final roll, on your next roll, you roll a 5. Now that counts as a turn. You rolled a 5, but you can't move forward. On your final roll, you roll a 1, and you get home. So this is where you win. This is where you've moved enough spaces to win. So it took you 4 rolls to get home. Now let's go back in time right here. It's going to be a little fun erasing this. On the next game, what do you roll first? What do you roll first right here in hand? What's the first thing you roll in this game? This one's a very quick game. What do you roll on the dice the first time you roll in this game? What do you roll the first time you roll in this game? A 6. So you go here. Nice job, Dan. 1, 2, 3, 4, 5, 6. Getting the numbers ordered is the harder part. And then what do you roll immediately after, which... What do you roll immediately after, which kind of just immediately does what it needs to do? You roll a 4, so you've won the game. Now the next one's going to be very interesting. So let me erase time right here. There we go. So that's easier. Now the next one, you roll a 3. Then you roll a 3. So I'll show right here. You roll the next 3. then you roll another 3, and you are 1 space away. So that 6 doesn't count, this 3, this 3, this 4. Now they're all rolls. They count as rolls, but you can't use it to get home until you get to here. So that time it took you 11 rolls, did it? It took you a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It took you 11 rolls to get home. So 11 rolls. This one right here, it's also going to be due to a 1 at the end because you have 1, 2, 3, 4. 1, 2, 3, 4. And then we have a 3 we can't use, a 3 we can't use. Then we roll a 1, and then we roll a 5, then a 2, then a 6, then a 1. And now we are home right there. Is this making more sense how we're doing the randomness right here? And I think I could code this into R. I could, for those, you know what we could do? I could code this into R. Let's check our answer right here. So what we're going to do is, one, we're going to look for the answer. Then we're going to see if R gets the right answer. So this one right here should stop here. So Dan, you ready? I'm going to ask a big question. I'm going to do this one. Okay. What number, how many dice rolls does this one take? How many dice rolls does it take to get home for this trial? This trial takes how many dice rolls to get home? So remember, you can't go over 10, and then you do count how many occur. So this dice roll takes how many trials right here? How many dice rolls does this trial take? 4, you're right. 1, 2, 3, 4. Because it'd be, this is the way I count it when I'm counting. I say 6 over 7, 10. So I'd say 4, 10, 4, 9, 10, 9, 10, 7, over, 8, 10. Now be careful. 1 trial, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow. That's the 11th trial. We don't need that one. So be very careful. You only want 10 trials. Usually they give you extra numbers. I've never had it equal up to 10. That's the first time I've seen 2 extra numbers that equal up to 10, which 5 and 5 and 4 and 6 are the only two, or 6 and 4 are the only ways you could get 2 extra numbers that equal up to 10. If you have extra numbers, you delete the extra numbers because it says do 10 trials. So the easiest thing to do now is to go down here to the very bottom and see that we have 58 words. It might be hard to see, but that's 58, or 58 characters. I did 10 trials with 58 characters, so how many times did it take on average? How many trials did it take on average for this? On average, if I did 10 trials and I had 58 rolls of a dice, what was the on average for this? 10 trials and 58 rolls of a dice. So I was like, let me just experiment here and see how many tries it takes. 10 trials, 58 rolls of a dice. So it took 5.8. Yeah, so I was a little afraid there. You make a mistake on this one and it says, nope, you added up wrong. It'll say, nope. You know what I'm going to do is I'm going to go back, way back here in time. Can I only go, oh, did time stop? Okay, good, time didn't stop. Time never stops. No, I might be able to do. You'll definitely, yeah, you'll get different numbers. You will get different numbers. It'll be very different numbers. Okay, good. I think. Okay, let's try this. Let's try doing this in R real quick here. This is good practice for 474, 320. So let's go over here. There might be a way to string split. Well, let me try something. Numbers. Okay, there we go. And it'll store that actually. And let me try something. Okay, hopefully it carried all those characters. I imagine it would. Split numbers apart in R. How to split a sequence of numbers into multiple quick tip. That's not how to do it in R. As character, string split. Ooh. It's missing. Argument split is missing with no spot. So it should be under string R. Yeah, I need to use string R. And if you have a question, feel free to ask. I'm going to just take a look at the strings real quick right here. String split pattern is missing. that. Oh, but it did it as that. We don't want that. It's taking the... Yeah, that's such a bummer. It's so long that it's messing it up. Well, we'd have to do it. Well, there's the long way of doing it. Or not the long, but... This is really good coding practice we're about to do right here. So we're about to do a little coding practice. And we got this big vector of numbers. It's not too long to do this, but let's say we had 10,000 numbers. We would not want to be doing this. We'd want to write a code that does it. There we go. Okay. So now we have all the unexpected. I'm missing a comma. Unexpected. How do I have one error? Or did I misclick? Where's the error? Oh my gosh, I'm an idiot. I can't think today. Once you've been this one, could you go over the... Yeah, let's do the z-score one first. We'll come back to this one right here. Z-score 1 is going to be more important. So to do a z-score, which goes back to 201, really good question right there. Thank you, Peyton. We'll come back to this one. I'll run this. I've got the numbers here, so I can do that in a second. But to do the z-score one, the z-score one is going to be, we need to know the formula for a z-score. Formula for a z-score is going to be the observed values minus the mean divided by the standard deviation. So as soon as we know this right here, we can start to turn it into something. So we can take a single value, such as, like, let's say Brian's height or something, 75 inches. So we go to the observed is 75 inches, the mean is 72, and the standard deviation is 3, and we obtain a z-score, or mean is 69. So we obtain a z-score. So the z-score is the observed value minus the mean divided by the standard deviation. But what if we took a vector? So you know what? We've got numbers here. Let's just do that. We've got, yeah, let's find out the z-scores for all of these. So now we could put here this vector, and we could ask for the mean of the vector, and we could get the standard deviation of the vector. And now all those numbers you observe up there are all now z-scores. So I've turned all of these into z-scores, but this is not a function yet. But the point of what we're doing right here is when you write a function, don't start by writing a function, write what you want the function to do. So we have our kind of skeleton for the function, and let's see here, z-score, and then we put return, because it's what we want it to return, and the only thing we need to give this is a what? What is the only input this needs to run now? So the only input this would need to run is a what now? This is kind of the beauty of running functions, which I'm going to turn this into a big function in a moment. I could simulate it with, I could do an advanced simulation here and like do more simulation, which would be kind of cool. It's so much easier if you generate your own numbers to simulate the dice rolls. It's so much easier because then you wouldn't simulate 0, 7, 8, 9. You can just say simulate numbers 1 through 6. So what is the only thing we need to input for this function? What is the only input my function will require right here? The only input it will require is what, Peyton? Or if anyone else knows. 100 points on the line. Who knows? Oh, the sound effect for this moment. The only input it will require is the vector. And so now we've created a function right here. So we go to z-score, and it mentions using scale. I think it says don't use scale, right? I mean, I wrote it, so I think it says don't use scale, and I'll show you what scale does. So if we go to scale of our number, or z-score of our numbers, we get this, and scale basically does the same thing. Scale gives you the characteristics also. It gives it more as a downward vector, but scale is the same thing. If you look at that, 0.46, 1.21, 0.46, 1.21. So yeah, no, it because scale does it. What I didn't want people to do was I'll show you what I didn't want. The really not, like the way of doing it that's not doing it is to go here to scale vector. So you could essentially, let me see here, what's it not like? Oh, it doesn't like, but there's that, oh. There we go. So now you could go z-score and z-score numbers, and it'll do this, but you're just running scale. You're running a function inside of a function. And you're not, like, this runs functions inside of functions, but this is just using the function. You're just returning the values of the function. Does that make sense? This is what my intended way of doing it, which we should all kind of know the formula for a z-score is observed minus mean over standard deviation. And then we should know vector mathematics we can do, so you can do it on a whole vector, not just an individual. So it's kind of a little bit of a knowledge check, a little bit of a coding check. And z-scores are very important. It's how we standardize information, and we're talking about them in clustering. So super important. What about does everyone notice this number, this vector right here? How about we go right here and we work on some conditionals? Think about the question we were doing with the randomness. Where do you get numbers from? What data set? Oh, just created right here. It's probably too big for me to copy into here. There you go. There's some numbers. It was just numbers we created. So you could just go here and store into this 1 through 100 and then run it on, I don't know, vector. You can run it on vector. And you can get the z-score of those numbers right there. Does that make sense, Lauren? Really good questions, Lauren. Can we make more mods? We'll try and make a mod. And did I delete my numbers? Oh, I deleted in chat. Good. So awesome. And so think about this. If we were to make up dice rolls right here, like let's say we had dice rolls, and we could, let's say we're going to help 201, our friends in 201, someone could use this actually. Our friends in 201, they're like, I'm stuck on this question. And you say, well, the first thing we have to do is we have to remove out numbers 0, 7, 8, and 9. So how about we write a code right here that says if the values of numbers are contained in the vector 0, 7, 8, or 9. So this right here, let's just look at this code. Oh, we got to do it an easier way. So think about this. There's an error I've already written. I've already written an error. Does anyone know the error Brian has made with his code already? It's kind of good I did this error, but this is not going to work the way I'm doing it. I can change it pretty easily. And I think I know how to write it to fix it. It's gonna be one line of code that's going to take away the 0, 7, 8, and 9s for us. But what's wrong with my if right now using this? What's wrong with the if and using this? Really good knowledge check. Why is if going to freak out with this? What's wrong with this right here with the if? An if only takes a singular true or false. I could do this with a for loop and it'd be a lot less fun. But what should I do to not use a for loop here? If I don't want to use a for loop, I've got a much easier way of doing this. So I don't want to use a for loop. I want to use something that will actually take a logical vector and do something for me. What could I do that would handle this? Close. I want to go to Ifelse. So Ifelse can handle this. And let's just do this right here, just for the moment. Do you see how it converted all those to 1s and 2s? So if it's contained in there, it puts a 1. If it's not contained there, it puts a 2. Or you can put it as 0s and 1s. Like if it's contained in there, 1. If it's not contained in there, 0. So the 0s, it's like a binary operator now. Does that make sense, Lauren? That this is taking this and returning back the values. If the numbers are contained in 0, 7, 8, or 9, which are not dice rolls, it is now returning a 1 saying it is in there. And you notice where the 1s are at. The 1 is in position 2. And right there, that's a number that is contained in there. The 1 is in position 4. And that's a number that's contained in there also. We could get the positions if we wanted with a which. And there's about a billion ways to do it. And that's why I said coding's like a fingerprint. So make sure don't send anyone your code, especially for this. So think about this. If the number's contained in there, what do you think we want to do to those positions? What do you think I should store to a dice roll that's not really a dice roll? What do you think I should do to maybe remove it? So what do you think I should store to those positions for dice rolls that are not really dice rolls? Because we don't want 0, 7, 8, 9 there. What do you think I should store in there? What would be a good thing that we could just remove it and make it not there? They say no one's home at this address. The person is what? What could we do? What could we do to make it, Lauren, 100 points, excellent work today. What could we do? could we store into that position? How about NA? Now we've made all those positions NA. And then guess what? I found this out recently, but you can put right here numbers. Look at that. Now guess what we're going to do? We're going to take and override our numbers vector with this right here. And now we have this. How about we remove those NAs with NA omit? We could have done it up there. Let's do it right here. NA omit on the vector we create and store over numbers. And it's put a class around it. So I think we need to do, gotta do so many things to get what you want. There we go. So what have we done? This code right here removes all the numbers that should not exist, and we get this right here. Now, what do we want to do this number? This is the hard part. This is the, I don't think we put a while loop on the test. While we want to go through and want to do 10 loops of this. So we want to do the sum of each element, and we want to do 2 while loops. No, we want to do a for loop, a while loop inside a for loop. This is where it gets complicated. So what we want to do is we want to start a counter here with I equal to 1. And what we're going to do here is we're going to go and we're going to say sum equals to 0. And we're going to go sum is sum plus, oh my gosh, this is good. I'm going to take 3 more. If you have a question, feel free to ask because there's so many conditions to this. But I've always wanted to write codes for these. Sum equals to sum plus the first numbers. And so this will sum up and increase that sum. And then what we need to do, object condition, because there's no condition, that's fine. We'll just run this. So that's going to add up and increase the sum. It goes to sum 6. But we need to do this. If the sum, if sum plus this is greater than 10, and then we say next. I think it should be able to do a next right here. Oh, is not allowing next in here? Go to, if you have a question, feel free to ask. Let me see. I thought there was a next. There is a next. It should be able to do that. Let's find out what happens. So if it's greater than 10, next. And then, and while sum is less than, not equal to 10. There we go. Well, the sum is not equal to 10. Run this loop. And we've got this right here. So sum save into sum plus the first value. And this needs to be I, because it's what will change. And at the end of this loop, we go here to I plus 1. So every time it goes through the loop. Okay. Oh, it needs to go I plus 1 right there. Let me think. Let me see what people are asking, if there's any questions. This is a tough one. This is a tricky problem, or at least coding it this way is. So if we enter into this loop, we could start right here with, I equal to 0. And then we could add the I right here. And that way it adds onto it right here. Okay, so now I is equal to 0, and it adds on the I right here when it enters into the loop. And then it checks to make sure it's not over, and then it'll add on the next I. And if it's not over, it'll run this code. If it's over, it will run the next one. That's what I want to see. I had a question about the visualization summit. Yeah. What are you wondering, Harrison? Feel free to ask. I'm getting this closer to being where it should be at, but this is a tough question to code. We're coding the randomness question. Which question do you have? Feel free to ask Harrison. I'll hop to that question as soon as you put it in the chat. I think this is about right. And so then we don't want to reset I, but we're going to reset the sum each time. So this will go into a for loop right here. Maybe I do have it figured out. I should have debugged it some more. And then this needs to go, doesn't matter, we're not going to use the numbers, we're just going to run it 10 times. I looked through all my X variables that were categorical and didn't recognize any that acted like identifiers based the ones that you told me to remove in the videos. There's supposed to be more among. You should have 3 of them. You should have 3 of them. So let me pull up, watch this, data. There you go. We got some data right here. So you should have 3 of them. So one, you don't want to go this crazy, but I'm going to go crazy. Now something, I'm going to try to send people to this part of the video. What are variables we shouldn't worry about? Well, one, and I think I mentioned this right away. I mentioned this in the video. That's an identifier. It says it's an identifier. So that is an identifier. And then let me make sure, do I have the data set you're using? I do have the data set you're using. And it is registering as, oh, ages. Whoa, did I click age? I meant to click this. Hopefully, I'm clicking original row number. If I clicked age and said that's an identifier, age is not an identifier. This is an identifier. So sorry if I misspoke right there or misclicked. But what can act like an identifier? So Harrison, really great questions. What can act like an identifier? What can act like an identifier? What variables can act like identifiers? What types of variables can act like identifiers? Categorical, you're right. So age is not going to be an identifier. High school GPA is not going to be an identifier. Anything that's quantitative over here with the blue icon, not an identifier. So big hints to everybody working away. So when would a categorical variable be an identifier or act like an identifier? Excuse me. Categoricals would be an identifier if it was unique for each and every observation. That's when it would be an identifier. When would a categorical act like an identifier? When would a categorical act like an identifier? When would a categorical act like an identifier? When would it act like an identifier? When would a categorical act like an identifier? When it has lots of... if it can't repeat, it would be an identifier. So if a categorical variable could never repeat, it would be an identifier. But, you know, in class, we mentioned things like your favorite ice cream flavor might be an identifier. Like, oh, that's the person who likes double chocolate chip road with triple strawberries in it. Like, that's such a weird, unique flavor. It almost identifies you. But if you only allow people to say chocolate or strawberry or vanilla, that's not really going to be an identifier. But if you say to someone, what's your favorite restaurant in Knoxville, that might be an identifier. Like, oh, that's the person who loves Taste of Thai because Taste of Thai is awesome. Or that's the person who loves Stock and Barrel, also awesome. That's the person who loves Hard Knocks Pizza. I'm just going to name off all the restaurants I love. But if you allow for so many options, that's when it can become an identifier. So with what I've done right here, do you notice anything? I mean, do you think honors with no and yes would be an identifier? Or do you see anything here? I'm not saying, but, and I'll let, you know, but I'm kind of saying, you know, do you see anything here which could maybe act like an identifier? Do you see anything here that would maybe, yep, bingo. Once you see it, it's like, oh, okay, I know what we're looking for. I know. And it helps if you just say, oh, you know, something's going on. I mean, there should be something kind of jumping out right here. So yeah, I think, oh, you can't really see. Yeah, there should be. Do you mind looking at number 4 in the coding practice? Yeah, put it in the chat. Yeah, put it in the chat. And if you click the scroll wheel down below right here, you can bring it up to like 1080. So try that, Harrison. Click the scroll wheel button. There should be a scroll wheel and it should say like 1080. Try clicking that. That should improve it. I want the eye right there, right? No, yeah, we do want the eye right there. Does this work? Let's try it. Oh, did it work? Oh my God. No way. I think I know why, because it went into the last. No, it didn't, because it. Did that seriously work? Wow. Wow. Use empty car's data frame and find a car someone is interested in. Your customer wants to find a car who's with at least 22 miles per hour. And so using the if-else. So the if-else right here is going to take a logical vector. And so we've got the condition empty cars. We want at least 22 miles per gallon. And greater than or equal to 22. I hope I did that today. Now I need to make sure when it says they want this and this, I put here an and empty cars. We want $ here that horsepower is at least 90. So we can see all the trues and falses right here. Might be other ways to do it. So one thing we're going to do is we're going to go to the if and the else. And when we go here, whatever is in the true spot, we could just put a 1 for the time and a 0. So there's the cars right there. And I think find a new car. So you could, there's so many ways to do this because you could, well, one, you could do a which, but it says using if else. I mean, I wrote it. So these are the ones they want. So yes and no works right here. The important thing to know is that if else takes a logical vector. And so the logical vector is getting turned into yeses and nos based on where the trues and the falses are. So whatever you put right here, if you put true like this, then those will go to the trues right there. So whenever you see true in this vector, like in position 3 gets converted into this. So you could do math or something. And so, yeah. And there's alternatives way. I thought you needed to return the cars' names themselves. You could, to do that. So if you need to return the cars' names themselves, you could do this. So that's got that. See, it's kind of, this is kind of, well, oh, no, wait. You could do this. I got a better idea. You could go to, if it is true, then you want to return names empty cars. And if it's false, let's try returning nothing. I thought it wouldn't like, let's try an A. Yeah, wait. That's names. Oh, we want row names. Or row names. There we go. And then let's go here to na.omit. I think it's going to do all that craziness it usually does. I hate that. And then as.character. And we really made a crazy version of this problem right now. But, and I'll nest this right here, make it look a little nicer. The main point of this problem is the if else. And so this is maybe the more advanced way of doing it right here to only get the names of the cars. But I did the if else, then I got the row names from what was given. I returned nothing else. I omitted those NAs and I turned it into a character vector only. When you use the NA omit, it gives you this extra attribute stuff, and I hate it. So attributes are just things that exist on a vector. It's like the seasoning of a vector. It's not really part of it. I don't know how to describe an attribute. It's not, you wouldn't be doing the math on the attribute. The attributes are extra characteristics on a vector that are not literally the elements of a vector. And you can do stuff to the attributes of a vector, but it's meant to tell you what's going on, these extra attributes right here. And that's where the NA action was done. So it's telling you when NA happened. And it's telling you this was an omit action on the vector that was done. But I removed it. I turned it just into a character vector. Does that make sense right there? So this is an advanced way of doing it. The other way is perfectly fine and what I really intended it to be. I intended it to be something closer to this. If you look at the key, I also did it this way. So this is my intended action right here. And we're going to show the power of coding, I think, because I wrote a function right here. So yeah, no problem. Can you describe the difference one more time between if and if else? Yeah, let's look at that. So if only takes a true or false, and the if will run the code right here if it is true. If this is false, it will not run that code. It does nothing. But you can put an else next to this, and the else will run. I didn't put it inside there. And so the else will run the code inside the code brackets if you have the if return a false. So ifs and elses can be connected, and ifs only take one true or one false. So you can't go inside of here and do a vector like true, true. It'll say there's an error here. You should only have length 1. And I think it ran it. It just only used the first. So you don't usually want to do this. It didn't do what it was intended to do. So you can only put one true or one false inside of here. And when you run false, it'll do the else or it'll do nothing. You don't need an else. So it now does nothing because this evaluates to false. And so going further, you don't usually put just a true or false. You put a logical check like is 2 equal to 2? And the answer is yes. So, well, because that's what we have returned. We could say no. We can make it really confusing right there, but it's just running this code right here. Whatever is here, it will run because this evaluates right here to true. Since that evaluates to true, it runs the code. Since this does not evaluate to true, it does not run the code, but you could put the else here once again, and the else will run. Make it say Brian, and there you go. Now, the difference with the if-else can be seen right here. The if-else can work on a longer vector. So the if-else, this is the first condition of an if-else, which is a logical vector. So a logical vector could be of length 1, so you could use just one thing, but you can see what a logical vector looks like. Now the if-else will run this code if there's a yes, or it'll run this code if there's a true, and it'll run this code if there's a false. So this is the true code that runs, this is the false code that runs. So you can see what this vector will be converted to: no, no, yes, no, 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 yes. And we can see that right here: no, no, yes, no, 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 yes. And that's being converted from the vector right there. Is that making more sense, Lauren, that a if-else takes a logical vector, and we could just use one part of this to make it not as confusing. So now it's converting that, but it just needs a logical vector. The logical vector could be of length 1, so you could just do a length 1 logical vector here. And so now this will just turn that into no. You'll just say no. You could do a length 5 logical vector, and let's see what a length 5 logical vector looks like. Yep. Yeah. Oh, that's awesome. You have to see these things 3 times. You have to practice. I mean, it's just tough. I can't tell you how many times I've looked at these and how many times I've been like, wait, how does an if-else work again? And then you have to remind yourself, and it just starts to become second nature. I was shocked my code up here ran for this because I think we've finally done it. I think we have a function. I need to remember to save this afterwards. I'll show this in class today. Let's call this dice solver. I see, I want to make it so and it'll take numbers. And okay, good, yeah. Good, and that's why I have it called down there. Okay, I think that'll do it. Okay, I think it's got it. So here's the real test. We're going to go right here. I'm going to reload the question. Now, the only hard part about this is going right here. Oh, we can't copy paste into here. We have to copy paste into Word first. That's interesting. So, and I wish you could just take these numbers as a vector easier. Okay, so we have the numbers in Word. And let's see if this works. Now we're going to go back to R. And we have to do this the hard way. We don't have class tomorrow morning, right? I think we're just reviewing. We are going to go through. We'll go through. Maybe we will just review. Maybe we'll just review tomorrow morning. We'll always have class, no matter what. I'll never, because we don't have class, I'm just getting a free day. You're like, but we want a free day too, Brian. And I'm like, well, but I get paid. I get paid either way, and I think it's better if I teach rather than say, you guys can have the day off. It's like I'll always be here to help. Awesome. I wanted the code to do this for us. I'm really bummed our code right now does not. I just couldn't find a way. Oh, I could have saved it as a character and string split the character and then went back to numeric. Okay, I've got still some. If there's more questions, feel free to ask, but I might try that here next. Let me put the numbers over here. So we're going to take the numbers. There's the numbers. We'll store it as a string. So numbers 2. We'll worry about that in a moment. And then we'll store it as a string. And then I can probably string spread it. Okay, I'll worry about that in a moment. Okay, so if this works, I can go here to dice solver. And I can put in my numbers. Oh, shoot. Oh, it's sum. Wait, how'd it work then? Oh, it's sum. It says sum plus I. Where'd it break? Missing value where true false is needed. Oh, because, wait. But it stored some. Should have it. How much time I got? 5 minutes. No, we're so close. It says it can't run this while loop. The sum should be created right here. If sum is not equal to 10, then run it. And no, what happened? 2 seconds. No, this is the end of the stream, and okay, what happened here? Got to pull the code out and try it. So it stores that. And then it goes here, and then it should store. Oh, is it storing? Why is it storing an A? Okay, that's where because the numbers. But numbers position 1 is an A? What position? Oh, I know what it is. I know. Wait. It's on position 9? Position 9 is an A? Position 9 is 6. Oh, sum is an A? This is so confusing. Because that runs. Wait. Okay. First number here is 1. Good. And then the sum is 0. Oh my gosh. Okay. And then it should go back into here. It should check this. Okay, that ran. Let me clear the global environment. Okay, let's try this again. I'll have to take a look. Minutes to go, and it worked. It gave the right answer, but now I'm wondering what's going on right here. There's 103 numbers there? Oh, is it because... Oh, we didn't remove the numbers. Where did we do... Okay. I know what it is. But wait. We need to overwrite this first to begin with. And so that'll overwrite it. And then it'll enter into the for loop. 6? It only took 6 rolls, computer. Oh, man. 6. Why is it saying 6? That's what it got to. Oh, it took 6 on average. That's the answer. It works. It works now. We've done it. We fixed it. Such a little error. So now it works. It's like, why is it saying 6? It was divining the answer. So we now have a solver for 201 that we can show. I might hang out for just a minute or two longer because I want to figure out this last bit right here and make it work. And this is kind of the coolness of coding because this question now becomes a lot easier. So if we were to take numbers like this right here, let's call this numbers 3. And we were to turn this into a string. Okay, good. I think that's done it. As long as I didn't make a mistake. And so there's all the numbers. And now we want a string split. Yeah, I think this will do it. String split, numbers 3. And we want to split based on this. There we go. As dot numeric this. Wait, why does it not like that? As dot integer. Really? Oh, it's a list. Okay, so we got to pull up the list. There we go. That's what it was. So many little things. I've probably lost everybody right now, but this is the coolness of coding. So then we go here and we just put, so there's the numbers. We need to call it numbers. And then we go here and overwrite numbers with this. And then we remove the zeros. We've got our dice solver. And so with our dice solver, let's check this out. So we just got new numbers. And so the new numbers are numbers 3. So let's just call this right here numbers 3. Let's store it. Let's run it. 6.6. Let's go here. Let's check it. It works. Okay, so now let's start the speedrun clock here. You ready? Let's see how quickly we can solve one of these questions now that we've written all the code for it. So after we've written all the code, we're just going to take this, and here we go. We're going to hit similar question. Let's do it. So here's the code, and the only hard part is now we have to copy this into Word, and we go here, and then we go here. We can get this done right here. There we go. And then we go there, we copy it, we bring it over, and we go to the coding. So we call this numbers 4. We're just going to store, oh, really? Oh, I didn't like the quotes. Should have done it over here. Go away. There we go. Now we go over here to numbers 4, run the code, 6.3, and they're under 1 minute solve, 40 seconds or so. We probably could have done quicker if we were just clicking faster, but I didn't know it wasn't copying it like that. But I'm going to show that off in 201 today to maybe show some power of coding. But this is kind of what we want to practice towards, is being able to think up, I'd always wanted to code this one. I was like, how would we code it? But we had to do things like take the words and turn them into numbers. We had to remove the 0, 7, 8, 9. We had to do 10 total trials. If it were to go over 10, we had to go to the next instance of the while loop. And so the while loop kept running. I like that next worked right there. But that's got it, some fun of coding right there at the end, showing what we can do for 201 that we could do in 474. But now anytime someone gives you that problem, you can just say, wait a minute, so watch. Better speedrun. We're doing one more speedrun. We got time. Class starts in 28 minutes. We're good. So let's see here. You ready? Similar question. Let's do this. Okay, here we go. We're taking this right here. We're going sub 30. We're going right here. We're going to a new page. We're going to copy it. Now we're not going to do the mistake we did last time. And we're going to copy it. Now we're going to go over to, I'm going to go right here. And then we're going to take the numbers, put them right there. And we're going to go to numbers 3. We have it. There we go. The answer is 5.5. We're good. The answer is 5.5. And boom, we got it. That's 25 seconds. 25-second problem. And we solved it pretty much as fast as we can enter in the stuff. If it was formatted better, we could just click the numbers, copy them, and solve it like that. But that's got it. That's the power of coding. Keep up the great work, everybody. Hopefully it was kind of neat to see what we can do with a 201 problem to turn it into a function just to make it solve instantaneously and do all the work for us. But that's got it. I'll talk to everyone later. Have a great day. See you 201 soon. Bye. 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 Bye.